graph is just showing that, I mean, it's roughly linear. The error bars are from the T distribution. Each one is 3 points. So it actually is roughly linear, but like I said, even at full power, it only will fill somewhat less than 1/4 of a liter a minute, which we kind of discovered anyway when we were going to fill the reboiler last week. We thought we would just put water into the bucket and refill the whole reboiler, but it was taking forever. This is the actual control panel, which you can download software and install and run it remotely, which I have done. I ran it from my laptop at home. One of the issues we've ran into is that to run an experiment, you have to refresh and get a code that goes in that window up in the upper right.
Left.
In order to collect data, it has to generate an experiment ID in the other corner. And as you can see right now, it's showing 0, even though it says I have 20 minutes of time below, and so it's not actually recording data. Which oddly, I've had better luck running it from home, getting it to generate an experiment ID than I have from actually running it here. I have no idea why that is. So you can see where you control the reboiler watts and the reflux percent, which is the amount of the reflux that's being cycled back into the system as opposed to collected as distillate. And also, you notice up in the upper left-hand corner below where the time is, there's a cooling water source temperature and a cooling water return temperature, which brings me to the next slide. On one side is one of the first really long runs we actually ran, and you see the cooling water source temperature doesn't vary much. It stays right about 28.5 degrees Celsius, with the return after it's ran through the condenser of 36.5 degrees. On Friday, I was running a run just to have data to compare to the other run, and noticed that for some unknown reason, the cooling water source temperature climbed all the way to 63.5 degrees Celsius with the return near boiling. And so I stopped the run and came by on Saturday just to check the system out. And these are, trace the cooling water. These are the valves in the cooling water system. I wasn't exactly sure why this one over here was off, and so I decided to turn it on, and then it dumped water on my head from this part, which is above the main. This is the main condenser at the bottom, and on top there's this little kind of smaller condenser.
Did you have your hat on?
Yes.
And safety glasses?
Yes.
And we have a clean safety shower. Making some points, but
Pretty clean water, don't you? It was just pure water that was in it. And so this week, our first thing we want to do is to figure out what's going on with the cooling water. And also, we haven't actually ran a run where we've collected distillate, so we're not sure how to operate that. And then to work on the operations manual to finally run an actual test distillation where we're distilling something other than just pure water, and to use that, all of that information to continue to design a junior lab using the methanol and water system. And actually, when I was talking about the cooling water, I forgot to mention that at the very top of the actual distillation column, there is a flow rate that reads 5.1 liters per minute. Originally, the reason we were running it to the idea that I would do a heat balance, an energy balance using that and the cooling water temperatures, but then I've been informed that that is a meaningless measurement or not an accurate measurement, so we have to figure out what our flow rate actually is. And that is a part of the cooling water issue.